already done the lecture slides, so let's go through concept questions. Alright, so we're in chapter 4. We already went through these lecture slides last time. So now let's look at these questions like we normally do. Alright? So, universal law of gravity, right? Newton's most celebrated synthesis is of what? Universal law of gravity. Huh? Say C. Anybody else? Say A. Earthly and heavenly laws. Synthesis provided hope that other natural phenomena follow universal laws. That should end the age of enlightenment, right? So yeah, so A, right? That's a little history. We're not gonna ask you that on the test. That's history. That's some, fine arts history or something. I don't know. All right, so don't even worry about that question. All right, here we go. Force of gravity between two planets depends on their what? Nobody? There we go. Nobody? Force of gravity depends on what? What did I tell y'all about gravity? Right? What did I tell y'all about? Huh? Say A? Anybody else? Y'all agree with A? Alright. Yes. Right? And that comes from this equation, right? Mass is right here. M1 and M2. And the distance apart. That's Newton's universal gravitational law. Okay? It's pretty straightforward. Alright, so if the mass of two planets are each somehow double, then what happens to the force of gravity? If I double the mass of two planets, I've got two planets, and I know that they have a gravitational pull between them, then I double their mass. Because the last question just said what? Gravity depends on what? Mass and distance apart. So if I double their mass, then what happens? Huh? You say what? B? Yes. Right? Because we just, what? Multiply by 2 times 2, right? Give us 4. Okay? Uh-oh. If the mass of one planet is somehow double, the force of gravity between it and a neighboring planet would be anybody? That's what we're here for. Gotta take a stab at it. Right? Get it wrong, it don't cost you today. B. Doubles. Right? So whenever you see this question, then what you should be doing is you're thinking about this equation right here. And when they say double, if the mass is doubled, that means I just multiply this times 2. Right? To double the mass of the planet means I just multiplied it times 2. So that's why the force of gravity doubles. Just like in the last one, when we said if we double the mass of both planets, then what would happen to the force of mass of gravity? Quadruple, because it'd be 2m times 2m. I mean 2m1 times 2m2. Okay, so that's what we're looking at, right? That's how we getting to arriving at those answers using this equation. We double the mass. Because on the test they might say, all right, well, what if we took half of the distance? Then what you got to do with that? Huh? Divide by what? Divide what by 2? Huh? The distance. All right? So we got to be very specific about what we're doing, y'all. So that means I'm going to write d over 2 here. And then when I square that, then what happens to it? When I square d over 2, what do I get? D squared over 4. So when I reduce the distance by half, then I reduce the what? Or I increase the gravitational force by what? Right? Because what's going to happen is I'm going to have d over 2, and I square it, I'm going to get what? What happens when I square d over 2? This is algebra, y'all. Huh? I can't hear y'all, man. Y'all got to speak up. I can't hear y'all. D squared over 4. So what happens to the gravitational force if it's d squared over 4? And it's at the bottom, then that means the 4 is going to do what? If I divide something by a fraction, then the denominator of that fraction does what? Goes to the top. Come on, y'all. I know everybody in here know how to multiply, add, subtract, and divide. If you don't, you would not be here. Okay? So that's all we doing. We ain't doing no high level, nothing. Okay? We just have to understand what we're doing. See, a lot of times we just guess. We just guessing, and trying to remember things. That's not how you do this. That's not how you approach this. That might have got you through high school, but it ain't gonna get you through this. Okay? The universal gravitational constant G, which links force to mass and distance, is similar to the familiar constant. And we went over this. Huh? Pi. Good. Right? So G is a constant. So it's a ratio of things. Just like pi. Pi is the ratio of the what? Circumference of the circle to the not the radius, the diameter. Okay? It can be the radius, but be the radius times 2. Okay? So here is pi, right? Alright. Now let's talk about weightlessness. All right. When an elevator accelerates upward, your weight reading on a scale is greater, right? And we remember that from the cartoon, right? You can go back and look at the slides, and that explains that pretty straightforward, right? What's that one? Okay, good. All right, love it. See. All right. I heard somebody say A though, right? Okay. Just make sure we understand what's going on. Like I say, if you don't, like I say, go back and look at the cartoon about the lady in the elevator. Okay? Now we're the wrong way. Yeah. Alright, now we're talking about projectile motion. Alright? Velocity of a typical projectile can be represented by horizontal and vertical components. Remember I said when something is a projectile, when I throw something, it's moving this way and this way at the same time. That's why it takes on that projectile type motion. Right? So assuming negligible air resistance horizontal component along the path of the projectile remains the same, right? So don't worry about that because that's a nuance that I really didn't go over, right? But just to let you know, in the horizontal direction, when you're talking about a projectile, there's no acceleration, right? So it's always assumed that things move at a constant speed in the horizontal direction. But where they accelerate is in the vertical direction. Don't worry about that. All right? When no air resistance acts on a fast-moving baseball, its acceleration is say A. Alright, good. So folks, that's why I say, see, we're getting a lot of this right because we're familiar with gravity. Because we live with gravity every day. You know, I don't have to remind you of how gravity works. Okay? So that's how you have to think about these things. You have to relate it to something you can easily identify with, right? Ball tossed at an angle 30 degrees with the horizontal will go as far downrange as tossed at the same speed at an angle of, well, don't worry about that, Dustin. We would never ask you something like that, but whatever, 60, okay. That goes back to this right here, all right? So let's look at the plot, and we see that what? 30 and 60 end up at the same spot. One just goes a little bit higher, right? Oh, this one? Yeah. Toss a projectile sideways, it curves as it falls. It will be an Earth satellite if the curve it makes. Let's talk about circular motion now. Alright? The satellite travels at a constant speed. The shape of its path is circle. Right? So Reason why that satellite is going in a circle is because of gravity. Right? Gravity of the Earth. Right? Reason why the Earth goes in a circle is because gravity from what? Sun. Right? So one is more massive than the other. The sun is more massive than the Earth, so the Earth is attracted to the sun. The Earth is more massive than the satellite, so the satellite revolves around the Earth. Okay? That's how you remember that. Alright. Speed of a satellite in an elliptical orbit, whatever. Varies. Okay. And y'all know that, right? If it's elliptical, then it's the closer it is to the center of the circle, it's gonna move a little faster. Right? If it's moving in an ellipse. Right? When a projectile achieves escape speed from Earth, what happens? What is escape speed? What is that? To break the Earth's gravitational pull. The rocket has to get up to a speed in order to break the Earth's gravitational pull. Once it does that, then it's in orbit. So now it's constantly going in a circle around Earth. But if it never gets up to that speed, then it's going to do what? Come back down and crash. Okay, just like if whatever you throw up, it comes back down. But if you were strong enough to throw it with the speed of a rocket, then you can throw something in orbit effectively. Right? But you're just not strong enough to do that. Right? Outruns the influence of Earth's gravity. Right? But it's never beyond it. Remember I said, gravity is never zero. It affects every inch of the universe, as far as we know. Right? So just because the astronauts are floating in space, they're still being affected by gravity. It's just very small. Gravity that you feel here on Earth is relatively strong. That's why you walk on the ground. Alright? So how long was that? I think we finished that pretty quick, man. We ain't got that much longer. So any questions for me at this point? Alright? So what I'm gonna do today when I leave here is I'm gonna add some more problems on mastering for chapter 4. So if you haven't noticed already, you got some work on chapter 3 to get done. Okay? So as I mentioned to you before, we're gonna pick up the pace because we're gonna try to at least get to chapter 7. Okay? By the end of the semester. We only got a couple more weeks, right? 3, 4, 5 weeks left. So we're going to be in chapter 5 next week. Alright? By the end of next week, we're going to be in chapter 5. But we're going to be taking another exam pretty soon on chapter 3 and 4. I'm going to let you know. I'm going to talk to Miss Marsha and find out when we're going to schedule it.
Tournaments last 2 weeks, so I missed like the last 2 weeks of classes. So I have my coach gonna send me the excuses.
Okay. All right.
I'm email to you today.
Okay. But you know that all of it's on the campus page.
Yeah, the lecture. Yeah. Thank you.
All right. Excuse.
Do you want me to show it to you now, or do you want me to just email it to you?
Yeah, just email it to me.
Okay.
I wouldn't do the original.
You said what?
I wouldn't do the original.
I ain't understand that first thing you said. Slow down. Slow down.
I had went to Mr. Reginald
Okay.
to give my people tax bill.
Whoever Mr. Reginald is. Who is Mr. Reginald?
Say it again?
Who is Mr. Reginald?
The man, he work in the what that building?
Financial, nah, that ain't financial aid. Next to the financial aid. I don't know what it's called.
Comptroller's office.
Controllers.
Yeah.
You didn't get your refund or something?
My people said I need the tax bill.
Oh,
Yeah, doing taxes. Yeah. Your tax return.
too
Tax
late now.
credits. Tax credit.
Right, taxes came out already.
He
Oh,
said he
yeah,
needed
what
it
you mean?
today.
It's almost over. It's April 15th, last day.
Right.
April 15th, the last day.
Yeah, that's what he said. My dad like to did it last week.
Have a nice day.
All right.